the online homework because it gives you no idea of what has gone wrong.
Yeah, and it was 90, the height was 90, and it came out to like 93,000, and I did the exact same thing as calculated. And it comes out all and I graphed it and everything, and like found the intersection of where it was supposed to be at 90, and it gave me some other answer, and I plugged that in, and it still didn't work. Like I tried all kinds of stuff to get the right answer.
Is this one working now?
That worked fine, but when I do H equals 90, it doesn't work. When it's 40, 50 on the bottom, it doesn't work.
I mean, it doesn't work.
Cosine or negative cosine.
It's the right process. So I don't know if it's having trouble taking the answer. So at least you're verified you're approaching it the right way. It might be some problem with WebAssign on that one problem. I don't know. They've had issues with some problems. But it sounds like your approach is right.
Can we go over E on that? Because that one is going really heavy. You have to isolate H out of the...
Oh, yeah. So for S to be 2450, we know at a height of 100 miles, it can see whatever it was you guys just said, 1,000 something. So now I want to be able to see like 2.5 times that much. So I'm going to have to be obviously higher up than 100 miles. But how do I backtrack? How do I solve, if I put in 2450 for S, how do I solve this for H?
First you could pull up that 7.1.
Eventually, what I want to do to kill that inverse cosine. What would kill the inverse cosine? Take the cosine, right? Take the inverse function. I can't do that yet because what's in the way?
That's 79.
Yeah, all right, so first divide that out of the way. And then you can take
The cosine.
cosine. Right, take the cosine of both sides. That's going to kill that. And then you just multiply the 3960 plus h up. Trying to solve for h here, so you just want to try to get the h alone. The first bad thing about it is it's in the bottom, so you multiply it up. And basically you can just say, if I multiply that up, I can divide this mess down. And now I just have to subtract 3960 and put all that mess in the calculator. So there's actually nothing new in there as far as an idea from algebra. It's the same idea from algebra. How do I solve an equation? I undo all the operations that are there. So I can get that variable by itself. So again, if you did that, I'm not sure what's wrong with WebAssign. It's having trouble. Did you ask that one? Who asked that one?
I did. I had screwed up the equation before, but I always have trouble. I don't know what it is. I always have trouble pulling variables out when they're in a situation like that. So there's like a top and a bottom.
Yeah.
I don't know what it is. It always gets me.
But I'll tell you this. The shortcut, oh boy. The shortcut for that kind of thing. Oh, that's much better. All right. If I had, let me just try to capture this idea. So this will be like a number, let's say it's 8, equals 3960 over 3960 plus h. Kind of with me, it's basically the same thing we have there. Just sound like the cosine is 8. The really cool thing I can do here is just switch those. That will always work because I multiply this up and then divide that down, so those just switch. So anytime you have a variable stuck at the bottom, you get that fraction by itself and then you just swap it out with the other side. It's kind of neat.
What is the same variable on the top?
Now, if you start talking about the variables in other places too, then you just do something else later. Once you if this was an h up here, you multiply this up.
And we divide each out after each.
Distribute the 8, get the h's together. We know what to do for our variables in more than one place. We get it all on one side and undistribute it, factor it out. Yeah. Do not let algebra be the reason why you mess up on a pre-calculus problem. Right? Do the best you can and not let that happen. That should be the part where it's not nice algebra, it's not pretty algebra, but it's just algebra. We should be able to handle that no matter how ugly it looks. Yeah.
On 448, number 48.
Oh, okay. So here's the gateway arch. That's yeah. That's it's a Godwin face.
That's better. That's better. Okay.
We demand our masters be good at art. It's too bad for you guys. So the arch here doesn't really doesn't really take a part of this question yet. Oh, number 48 and 6-2. Let's talk about the gateway arch. So somebody's flying, they know they're 35,000 feet off the ground because they got instruments to tell them that. She'd like to know what exactly. What part of this would she like to know? Now I got to read it.
It gives you an angle.
Ah, cool. So the distance from her plane to the arch. And I'll tell you this, they really just mean that. The weird thing about it is you don't have to know the height of the arch. They're not getting into all that specificity. You with me? And then part B is going to ask about this. So part A is this and part B is this. Part A is all about how far is she from the, between the plane and the arch. Now the part that I think you might have some trouble with, and we might as well clear this up right now, is this angle of depression, which sounds like some weird melding of math and psychology, but angle of depression or elevation is always measured in relationship to looking straight out. So if angle of depression would mean go down from there. So if I'm looking out over the Grand Canyon and I see something stuck in the side of the canyon at an angle of depression, I'm looking down into the canyon. Right? Does that make sense? No? Straight out, I look down into the canyon at an angle of whatever. So this angle of depression would be here. How much below horizontal are you? Angle of elevation, I look up to see my kite, the angle of elevation from straight out. So it's always measured in respect to straight out, horizontal. Okay. So we are pretending like that is horizontal. So that's the first thing you realize is that angle, of course, is outside your triangle, but it's easy enough to work inside of it. What's this angle here got to be? 22. Alternate interior angles. And now you can answer the question pretty easily, hopefully. Like for part A, how far is she? Well, what relates what I want to know with what I know? What relates those three things? Which trig function?
Oh, sine over.
Sine. Sine is y over h. So for part A, it would be sine of 22 equals y piece over h, which in this case I'm calling it A, just because it was part A.
We can represent the hypotenuse as A. Just
Oh, hell yeah. You could represent it any letter you want to.
J.
Even any alphabet you want.
J.
Huh?
J.
Sure.
Yeah.
Yeah. Whatever that was. Yes. Is that cool?
Yes, sir.
Yes, sir.
I did it, but none of them did it right, so people might give us the answer.
It's whatever 35,000 divided by sine 22 is. And how do you do part B? It's basically the same thing except you use cosine. Because then what I want to know is the x piece, and I still know these two things. I would never base later parts of a problem on something I had to calculate if I can avoid it. Does that make sense? If I make a mistake here and then I do part B using that, then I've gotten two things wrong now instead of just one. Say again?
Yeah, two.
Oh yeah,
3 million?
3 million.
Yeah, it's almost a negative 3 million. Yeah, no, that's not right.
Yeah. Do you know why that's happening to you? Possibly. What do you always have to be careful
Oh, yeah,
about?
we're in radians.
Ah, yeah. You're doing 22 radians.
Oh, yeah, then you have to do
22 radians would be, wow.
Yeah. Okay, let's try that again.
Yeah, exactly. And because my picture's really not drawn very well to scale, I mean, 22 degrees, here's 45, so 22 would be this. So you got to go all the way out, and this is 35,000, so this should be like
Long.
pretty damn long compared to that, right? Okay. But this kind of problem should actually be easy. As long as you can draw that triangle and get the angle inside, you should be able to set up your ratios or figure out which trig function relates to the ratio you need. So this is exactly the same kind of problem as a ladder leaning up against a building, the very classic trig problem. It's the exact same problem. It's a little bit harder because this one didn't give you the picture. You had to draw it. So number one, you had to understand what angle of depression meant. And number two, you had to know how to work it into this triangle. Now, if you could also do this, what would this have to be?
68.
Yeah, this has to be 68, which makes that have to be 22. You don't even need them. You can use 68. You can make trig ratios using 68 degrees. Why the hell not? Okay, maybe. Yes, sir.
In a question like this one, where it did the Sandler one, where it didn't show up with whether it was in radians or degrees, how do we decide if it's ambiguous? Do we just always as default go to radians?
Yeah, definitely. If the good question, whenever this inside is real numbers, I mean those were measurements in miles. That's going to come out to radians. Because then that ratio is going to be, what am I trying to say? Miles to miles, so the units cancel. And whenever units cancel like that inside of a trig function, that's going to be radians. Radians are effectively almost a dummy variable in place of when things cancel.
Okay.
Yeah, so remember this equation?
Yes, sir.
So if S is in meters and R is in meters, S is in meters, R is in meters, theta is effectively in no units at all. Has to be, right? Because my answer is not meter radians. Yeah, it's about 48 meter radians to where I want to be. What are you talking about? So radians is very interesting. It's like a placeholder. One of my teachers a long time ago, you called it a placeholder unit. It just steps out of the way when some other unit comes in. And we see that often. So here, this is miles divided by miles. They'll go away, so then the radians come and say, okay, I'm here. Units went away, it's okay. Hold on. So that's the real number, yeah. So almost all the time when we're plugging stuff in inside of a trig function, it's almost got to be radians, unless it's defined to be somehow degrees as an output on the inside. Does that make sense?
Yes, sir.
Here, it's got to be radians. Let's do another one like that one there. Let's see. Oh yeah, this is interesting. What number 60? This is not 75 over.
Yeah, I don't like those. I like the more, I don't like this scale.
So to measure the height of cloud cover at an airport, a worker shines a spotlight upward, angle 75 degrees from the horizontal. An observer 600 meters away measures the angle of elevation to the spot of light to be 45 degrees. So he's standing 600 meters away. Shine the spotlight. It's powerful enough to last until it hits the cloud. I can see where it hits the cloud, and I see that it's 45 degrees up that I have to look. You guys kind of still with me? This is a nice one because they drew the picture for you. Thank God. Right? Still have to figure out the trig work. I love this kind of problem, and this kind of problem shows up in a lot of different ways. Where we have this that's a member of two different right triangles. We've kind of seen that idea before. You'll notice what's really funny is when you get into law of sines, law of cosines, if you look back at some of these problems in this section, you're like, that would have been quick if I would have known the freaking law of sines or cosines. But that's too bad you don't. Let's be real careful. In general, you got to be careful. In mathematics especially, it gets rough when you're behind on homework or you're trying to catch up. You got to know what you're allowed to know in a section. Does that make sense? In the next chapter, in this chapter we talk about these identities. In the next chapter we talk about other identities. You better not use any of these here. But it makes it easier. I don't care. You don't officially know that in that first section. So here we don't know law of sines and cosines. Where I want to go with it. Oh, so they want to know what the height is. So what's the best I can do? Like what's this going to be here? So we can call that x because I have no idea. But then what's this got to be here then? 600 minus x. Now what's one way to write something involving h? Let's say maybe this triangle here, this right triangle here. Using this first right triangle, what can I write? Which trig do I want to use relating the two, the thing I know and the thing I want to know? Yeah, tangent. So tangent of 45 equals h over 600 minus x. So h equals that thing. What is tangent 45? I heard it. What? All right, and if this is 45, this must be 45. So that's a nice isosceles triangle, 45, 45, 90. So these two sides have to be the same. And you can tell from my picture they obviously are. Now, what can I write on number 2? Again, yeah, tangent's going to relate what I want to know with what I know. Tangent 75. Now, which variable is it that I don't care about in this problem? And some of you guys are like, anything up there, man. X I don't care about because the question is all about the height. So I want to get rid of x here, so then over there I can just be more specific. Plug what in? So what do I have to do first here?
Divide x.
Solve for x. Sweet. So I can't plug in x until I solve for x. So x equals that. So then I can plug that in there and then solve for h. Yes, sir.
Couldn't you just add x and then subtract h from the other problem?
Yeah, you can solve for x here and plug it in there. As long as you solve something for x and plug it in the other guy, so you only end up with h. Either way. And how do I actually solve that then? H would equal 600 minus that mess. What do I have to do here? And what do I have to do first in order to do that?
Rationalize the
Divide by
denominator.
87.
No.
Are you going to practice something?
No.
Keep guessing.
I love it. So again, somebody was asking me about the reason so many people do really bad in math is they think that every single problem is something new to memorize. Whenever I'm trying to solve for a variable, I get all of that variable on one side first, right? I mean, all the variable on one side and all the other crap on the other side. So here's some H stuff. Oh crap, let me bring it over here. Now all my variables are together.
Take out the H.
Take out the H here. And then divide by the 1 plus 1 over tangent 75. If you take out an H, you'll get that. Divide by it. And then whatever the hell that is. Be really careful plugging this in the calculator.
Do we have to change it to radian first?
No, it's degrees.
Oh, okay.
All right, sure.
473.2.
I don't know. I'm pretty sure this is not the way it's done anymore. I don't know. I would hope it wouldn't be. Might be the same principle, but then I hope they use lasers just to see how long it takes for them to come back.
Is that the same or a similar process as number 64? That one was actually assigned.
Sort of, yeah. The same kind of idea. Yep. Very, very similar, yeah. Okay.
126, I come up with 126.17. Does it make sense with the height?
Oh, let's see what he is supposed to do. I get 473.2.
I got 600 first, then I got 126.
All right, take the average, and that's pretty close. I don't know. You just gotta be careful how you plug it in. 600 divided by
Make sure your calculator's in degrees.
parentheses.
Yeah, and 1 plus tangent.
And also, Jan said, make sure that you're in degrees. That you're in degree mode, yeah. And it should come out.
This one will come out wrong.
This is true. Okay. Let's see. One like that. No, it's weird. Oh yeah, here we go. Oh, that's cool. So we got this here. All right, guys. Before we move on, let's do one more like that. I'm looking at page 485 in the review. Number 30. This is actually on the practice test with a bell. I like this problem. So here goes another plane. There's my plane. And he's got two ships down here. Okay, so the angle of depression to the lead ship is 40 degrees, and to the ship trailing is 52 degrees. If the pilot is flying at an elevation of 35,000 feet, find this distance here. I like it. So let's redraw this triangle without all the ships and planes and stuff. So I've got two triangles here, really, two right triangles. If that's 40 and that's 52, so we can piece this together. These are parallel lines, so if that's 40, then what else must be 40? Here or there?
There.
Good. There. This is the transversal for these, so that's 40, that's 40. And then if that's 52, then this must also be 52. Is that cool? So we have a right angle, because that's directly down from the plane. Here we have 52. Here we have 40. And does that make physical sense that that would be smaller than that? Hell yeah, because I got to open up a little bit more to see to that same point. This should be a little bit smaller. It kind of makes sense. It's got to slant more back than I would here. It's got to be a little more open there. All right, there's plenty of that. So what I'm trying to get then is this side here. And I know that this is 35,000. Now, you'll notice a trend in a lot of these problems, and I like to do this kind of problem on a test. Where you've got to write two equations and use system of equations ideas to solve it. If you could use law signs or cosines, this would be a lot quicker. But again, you can't.
So will you do this like on the question? Do you do something like this? Would it have the picture there, or would it be straight up word problem?
I don't know. I'll think about it. So there's two right triangles here. Considering the section I'm in, I have to use right triangles. Right. So the two I'm looking at are this one and this one. And I'm curious about that part of it, but the fact is there's no way for me currently to do that, and that's where the law of sines or cosines would come in handy, right? If I wanted to see this triangle, it's not a right triangle. But too bad for me. So I've got this little piece of Gerda that I've got to worry about too. What do you want to call him? I like him. We'll call him. So here's where you got to be a little bit comfortable just writing down what you can and seeing what makes sense. You always want to relate what you know with what you want to know. So I know this. So for the 52 degrees, for example, what can I use? I don't know the hypotenuse at all. And I don't want to know the hypotenuse.
Tangent.
The tangent. Tangent of 52. Careful now, I'm looking at the little triangle here, right? The little right triangle?
So it's like this one or that one?
Yeah, 35,000 over P, Y over X. The Y side over the X side, let me say it like that. That's one equation I can use. What's the other equation for the big right triangle?
Well, we know 40 degrees.
Tangent of 40.
Tangent of 40,
35,000 over P plus X.
35,000 over P plus X. And really, this is the kind of problem where I find it difficult. I really find it difficult giving you any leeway with this kind of problem because you've desperately got to feel okay doing the algebra here. I know there's a trig function sitting there, but right now that is a number. Tangent of 52 degrees is a number. So this problem is now officially an algebra problem. This is a system of equations problem that if I gave it to my Math 90 students, they would understandably hit me in the face and leave. Because that's a little bit more, if I put a number there, they'd still freak out. But we should not freak out. You guys should not freak out, because you know what to do. Which letter do I not care about? P, because I need to know the x. That's what I want. So I want to solve one of them for P and plug it in the other one. You can even solve them both for P and then set them equal to each other, because then P would go away. So you have a couple different ways to do this. Yeah, so I can take number 1 and solve it for P. And then I can plug this in there. Now to tell you honestly, what I would do is I'd clean this up just a little bit. And then I plug it in so it doesn't have like fractions inside of fractions and all that. So now I can put that there and then solve for x. In which case it's really just one step away from being solved for x. So there's the overriding idea of how to solve systems of equations. The most general way we do it actually is substitution, because the elimination method gets really ugly because our coefficients could be gross. So the general method is solve for a letter, plug it in the other one. Does that process care what the hell functions I've got in there? No, it doesn't give a shit about that. So this is nothing new. Okay. Maybe. So you'll get x equals 35,000 over tangent 40 minus 35,000 over tangent 52. And I have no idea. Whatever the hell it comes out. Anybody want to hazard a...
14,000.
Yep.
14,366.38.
Cool. I like it. Miles or feet? This is feet. Miles, that would be pretty damn up there. Feet. Yeah. 35,000 miles up. Holy shit. Playing some trouble. That plane better be from Richard Branson stuff. Okay. Now I'm not saying. All right. So you have a your job now is to get comfortable enough with the trig that you're able to not let it freak you out when you have what's relatively an easier problem here. So the trig is what helped me set these equations up. Then you let it go and you just attack it with algebraic ideas, right? So the trig here, this is what freaks people out. I understand when you first see this, you desperately want to be able to get there directly. And a lot of people try to set one equation up that gets that, and you can't. Not without using law signs or cosines. And even then you have to have some other equations to set up. But you just have to look for the right triangle and then set up what you can. Compare what you know with what you want to know. What you know with what you want to know. Make sure that you're using the right trig function to do that. Yeah?
On the test, are you going to have questions worded without using the law of signs or whatever it is?
Yeah. Definitely. Because of that case. And then what I like to do sometimes is I'll have you do one, and then I'll say now using the law of signs or whichever one's appropriate, do that problem again. And so you'll say, okay, that's easier. Right? And then you already know what the answer should be. Anything else from homework? Okay. Those of you who are still with me. All right, so then we're going to get into chapter 7. You want to take a break? I really. How about like a 10-minute break? I really just want to do 2 sections today out of chapter 7. So it should be relatively short. Do you got enough? You guys want to take a break?
No,
You guys-
no.
Do we want to keep going?
Yeah. Just
How many want to take a break? Anybody? All right, we'll take a break. Let's come back at 2:20. I hate democracies.